Welcome back to one more tutorial on Pytorch. So here we are going to implement linear regression in Pytorch. Okay, so I hope you are well familiar with the concepts of linear regression. If not, I have a blog here for linear regression. I have explained everything in details here. I will provide the link in the description. Okay. Um, Other than that, just let's start coding. Okay, so before coding I just need to tell you two things. That is, one is that torch only takes tensor type objects, so we need to convert numpy arrays into tensors first. Second of all, loss functions like mean squared error and binary cross entropy only take float32 type variables. Okay, so we need to convert all of them into float32 type. Again, there are some changes like softmax only takes double and these kind of things are there. So the thing is, I will explain those in later videos when we come to those parts. First, let's do linear regression. Okay, so first what I did was I take a random took random in samples for x and random in samples for y. Okay, I just multiplied x with random numbers because I needed to make it a bit collinear for the linear regression, or it will be completely scattered. So that's why. Okay, so the next thing is, okay, so we have this numpy array, right? X numpy array, but this is not how our machine learning model will take. So we have to reshape this one. Reshape in -1, 1 in this format. Okay, so let's do that. X equal to this, and similarly y equal to y dot reshape -1, 1. Okay, so we have that done. Now this next few line of code will be same for every model we are going to build using Pytorch. So you can remember it, you can write it down somewhere, do whatever you want, but this will be same for every part. So we have to define a class, say it's linear reg. Okay, and here we have defined torch dot nn dot module. Next part is we have to define the constructor, that is init, which is called in Python init, and self, the self. Okay, self will be enough here. Super of regression comma self dot init, and one more thing is forward function. Okay, and we'll have to forward. Okay, and out equal to. Okay, so this part, this up to this line of code is common for all the models. Okay, the next part we are going to do, it will change for model to model, but this part is same for everything. Okay, you can name it anything, linear regression, logistic regression, whatever you want. Okay, but other than that, all will be same. So now let's define the layer. So let's give it a name, linear equal to torch dot nn dot linear, and here we are going to give the input dimensions, output dimensions. So the input dimension is also 1, output dimension is also 1 because it's a linear regression. So simple linear regression actually. So it's a 1 to 1. So 1 comma 1, and next we are going to define the forward function, which will give us out equal to okay, this is a mistake, it is self dot linear, so it will be self dot linear and pass x into this, return out. So that's it for our model. Now we have to define loss function, define optimizer, and the model itself, obviously. So model equal to linear reg, and that's it. Our loss function will be torch dot nn dot MSE, mean squared error loss, and optimizer will be torch dot torch dot nn not n dot optim dot sgd. You can use Adam also if you want. I'm using sgd here. So model dot parameters. So we are passing the model parameters here. What are the model parameters? Okay, let me that define the learning rate is 0.01. So model parameter is like here our function is what, y is equal to mx plus c, right? So the model parameters will be m and c. Okay, these values are the model parameters. M and c will be the model parameters. So that's it. Now let's train the model for epoch in range of, let's take 100. And okay, one thing more before we go to that is, let's convert this x and y into tensors. Okay, here okay, reshaped, and let's make that y reshaped because, well, we would need this for the plotting again, so that's why. Okay, and that's it. So capital X equal to torch dot autograd dot variable. So we are going to convert that numpy array into torch tensor types. Okay, variable. So for that, from numpy to tensor, we have a function called from numpy. Okay, this function can be used to do that. X re, and we have to convert it as type float32. As I told you before, it only takes float32 type. Okay, and similarly for y, torch dot autograd dot variable torch dot from numpy y re dot as type float32. Okay, so we have converted this into x and y. Let's see what is x and what is y now. See, so the numpy array has been converted into a tensor type objects. Okay, so epoch in epochs, the first thing we now need to do is, so let's say prediction pred, and what will be the pred? Pred will be our model. We're going to pass the x variable we defined here into our model. Okay, and now loss value. So how much, what is the MSE value we'll get from here? So that will be our loss function and predicted comma y. Okay, yeah, now we need to do is optimizer dot zero grad, so that and loss value dot backward and optimizer dot step. Okay, so what it does is that loss value dot back means it is passing the updated value, that the updated value of M and C back into the model and thus changing it. That's how our model will have the perfect line which will pass through the data points. Okay, and that's it. And optimize the step is changing that helping with that, whatever. Okay, now okay, let's print this last function. Okay, print epoch comma loss val of 0. Just do it for a loss val. So as you can see, this is our loss value for 100. Okay, this we can plot that also, like if you want we can plot. So basically what you're going to do is just find a prediction. For finding the prediction, the same thing we have to go do and apply is a model, and we are going to pass the x values, right? So you can directly use the ax, or you can just do the same thing again as you did here, that is torch dot autograd dot variable and torch dot from numpy xre that dot data. Okay, okay. Okay, somewhere it is there. Okay, we didn't convert it into as type float 32. That's why it's giving that error. I told you that's a pain in the ass. Okay, so we got that, and now data dot numpy. What dot numpy does is it converts the tensor type variables into numpy. So you can check here what is the pred, and here is a numpy of type float 32, numpy array of float 32. So now let's plot it. So the same function, what is, I'm just going to copy and paste this one, nothing else. Okay, we have this, and copy paste, and plt dot plot prediction pred, and let's see what the happened. I think I made some mistake here. Just give me a second. Okay, so what I did wrong was I didn't convert this, right? So it's basically x is a single dimensional array and pred is a two-dimensional array, so we have to convert that first into reshape. So reshape 1 comma minus 1, and still what will it happen to 0, and give x comma this one, so it will be mapped along x-axis. So what does this does is, see, when we are using pred dot reshape, it will give us a two-dimensional array, but like each one, the first has one more dimension, that's it. So we need to take this one, only this part, that is why it's I have given dot of 0. And now let's see, perfect. So as you can see, we have got the perfect line, the best fitting line here for the x and y data. And that is the main objective of our tutorial. Okay, one thing else you could have done is you could have mapped the log, plotted the log for log variable, but yeah, that much is okay. So this ends our tutorial for linear regression, and I hope we'll meet again. Bye bye, and meet you in next tutorial.